in the field of artificial intelligence, while artificial intelligence still was yet to come. I have a professional background right now in digital transformation for around about 10 years. Growing up in Accenture, where I served as a delivery lead for digital transformation projects for 5 years. I co-founded the artificial intelligence capability back in 2016, and soon thereafter became AI operations lead for Europe in Accenture. And then 2 years back, I wanted to focus more on the industrial side of things and continuously push on digital transformation in the industry sector. So this is why I followed an invitation by Siemens to join their consulting arm, where I am now heading our smart automation capability. And I'm currently tending to one client in Oman to accompany them on their digital transformation journey. So with this, I would like to start off today's session on the challenges of combining enterprise and industrial AI. And to start off, I think we have all been part of the disruption that digitalization has brought us over the past decades. So since the rise of the smartphone, roughly in 2007, computing power and data generation has become ubiquitous. So the edge was born and gave rise to what was then known as big data. And then in 2016, we were part of the historical event that gave rise what is now the major fuel of the fourth industrial revolution, the victory of AlphaGo over Lee Sedol. For the first time, a domain that was long time believed to belong to the human intelligence alone was conquered by a digital system. Since then, artificial intelligence has brought many more major breakthroughs, both within itself and basically any other scientific field, business and industry. We see medical diagnostics being disrupted by very advanced AI systems on an almost daily basis. In China, the most common medical issues are now diagnosed by a walk-in AI that not only does the diagnostics, but also immediately provides the prescribed medication to the patient from a deep freeze storage that is directly located underneath. Google's duplex technology, revealed in 2018, brought a near indistinguishable conversational AI to the stage. Thereafter, we were soon engaged in discussions about the necessity of artificial intelligence systems to identify themselves in human-machine interactions, because we could simply no longer distinguish between an AI and a human person while we are not interacting with them on a face-to-face level. This again was superseded by the introduction of GTP3 last year, the third installment of OpenAI's generative pre-trained transformer network that provides unprecedented quality in auto-generated language, which will pave the way for entirely new human-machine interactions. So hello, Siri 2.0, and hello, the talking computer. And only in December last year, Google's AlphaFold solved one of the big chemical challenges that, if we had had that breakthrough only 1 year earlier, could have helped us so much to significantly reduce the impact of the late COVID-19 pandemic that has been oppressing our lives and impacting our lives for the past 2 years. This breakthrough was not expected until the mid-2040 years. So with the help of AI, we are now seeing technological breakthroughs being enabled decades earlier than we would have expected them to come up. However, with all these advances, it seems that while we are celebrating grand successes in technological depth, we are still struggling with the application on the broader scheme of things. So today, I would like you to invite you on a journey to explore how we address these challenges at Siemens and how we scale artificial intelligence on an industrial level. So let us look into things. While we have a feeling that basically the application of artificial intelligence systems at scale is slow, we tried to get a little bit more to the bottom of things and conducted a broader survey with the help of Algorithmia in 2019, which was then followed up by Porsche Consulting in 2020, which confirmed our suspicions that basically by this time, even 5 years in after the actual technological revolution happened, about half of the enterprises are still in a very, very early exploration phase. And only another third of the enterprises are actually in an early adoption stage. But only about 15% manage to actually successfully deploy artificial intelligence within their industrial and day-to-day business. Out of the solutions that are built, a staggering 9 out of 10 solutions never reach the deployment stages. So the question is, why is this happening? And part of the problem is that basically in an overwhelming percentage of cases, artificial intelligence and these technologies are developed by internal teams that oftentimes are not fully equipped to address the challenge. And it is in quite some times it's driven by the wrong ideas. Basically, there still is an understanding or a perception within companies that it is quite feasible to achieve the same results that Google or Facebook, Amazon, or looking at China, Tencent and Co. are achieving with a fraction of a budget and oftentimes less proficient teams in a small amount of times. So here we need to shift away from the idea that we can develop new technology for ourselves, but rather become a very, very proficient applicant of new technology. And on the strategic side, we see that especially smaller companies struggle in formulating a precise vision and strategy for AI, but also in enterprises. We see this is becoming an increasingly significant challenge to formulating a business strategy. Oftentimes because simply the technological voice is missing in the gremiums that formulate a business strategy and thereby are never heard. And this is backed by a perception in major business departments nowadays that actually business is still driving technology. However, this perception is really outdated, and business and technology is business to a certain extent. So if we want to address these challenges, we have to look at what we describe as more or less the holy trinity of AI and technological adoption, which is a centerpiece between business, people, and the underlying technology layer. And as we can see, the technology layer and the people layer form a foundation. On the technology side, we have a strong dependency on a good application of tools and frameworks, a healthy IT footprint that enables us to have a solid, sound, and thriving data landscape and catalog, basically, that captures and allows us to accurately process the data that is generated by our business, which then in turn enables a data-driven IT architecture where at the focus piece of all the decisions that are taken in our IT department, the enablement of data-driven businesses is at the center. And this in turn is subsequented and complemented by a precise collection of product data and process data as well. Because in reality, the processes are hardly followed the way that they were originally designed, particularly in cases where these processes are older than information technology or have grown at the time where ERP systems were still in the children's schools. On the people side of things, it is imperative for us that we have the right understanding and the right mindset in our workforce. This must be fostered and enabled, and it's not naturally given, particularly because of the fact that IT and technology is nowadays invading any business, any sector, and any proficiency. It doesn't matter if I am a financial accountant or a lawyer or a nurse working at the hospital. All of my, wherever I am working, my entire job life is invaded and impacted by digital technology, and there's no escaping. And typically, depending on what kind of workforce we are looking at, many of these employees are not digitally natives. In fact, many of these people might have particularly chosen their field of working because they do not like to engage with technology and rather prefer to be engaged with people. And now there's this technology vector coming in that in many cases is way outside of their perception. And that causes all sorts of problems when you look at the people side of things. Simply because even if we provide the right tools and means for our employees and workforce to collect the relevant data that we need to run and operate our business, that doesn't mean that the people have the right understanding on why is it necessary to perform certain actions, particularly if these actions do not seem to have any impact on their immediate step along the value chain creation. But if in an upstream part of the value chain, certain data is not properly entered and maintained, it will severely impact all the subsequent steps and the downstream parts of the work stream. So from this perspective, education and creating a sense of understanding and urgency then once we set this foundation, we have a third route that can only emerge at the point in time when we have a proper enablement on the people and technology side in order to allow us to become a data-driven business that then ultimately adopts digital technology and data at its core and allows us to entirely rephrase our business model and then create all kinds of new fruit that simply emerge from the synergy of all these three domains. When looking at an industrial context, the big challenge that we are facing nowadays is to connect the physical world with the virtual world in order to create new insights, new value propositions, reduce operating costs, and come up with new ideas that will ensure we have and maintain a competitive advantage. However, this poses a very significant challenge on multiple domains. One is we typically in an industrial environment are faced with a very diverse mix of legacy infrastructure and modern machines, especially with the old legacy infrastructure not natively coming with the required connectivity and sensor systems that we would need in order to collect relevant data. Also, this then only is an open loop control system where we cannot digitally employ a feedback on the machinery in case we register anomalies in the operation. Then at this scale, AI operations have to be trustworthy, secure, robust, and reliable. Right? Because if we change the environment, if we change any parameter in the real world, it will impact the virtual world massively. Because if there's a significant deviation in the physical world from what we modeled in our virtual world, we have a disparity, and caused by this disparity, we will diverge from each other, causing miscalculations and in severe cases, even catastrophic failures, right? An example might be the design failure that we saw in the 737 MAX, where basically the loop was not closed in such a way that it prevented a catastrophic system override. Now, let us take a step back and look at a little bit at what we at Siemens mean when we talk about industrial AI. So on the enterprise side of things, we have the typical artificial intelligence applications such as sales and demand forecasting, AI-driven accounting, channel management, intelligent automation, analytics-driven fraud and debt analysis, risk modeling, business process redesign, etc. So on the enterprise side of things, we try to harness artificial intelligence and automation to drive the digital transformation of our business processes and the business itself. However, most of these applications are really domain specific, rather narrow in focus and drive a depth of value, but lack a certain scale and breadth of value. And this is where we start to look at the industrial side of things, which emerges when we start connecting the physical and the virtual world. So this starts at something that is asset indexing and monitoring, associated predictive maintenance, service intervention. Then we look at physical, but also digital security of our assets, real-time forecasting, quality inspection and assurance, and also AI operations and AI DevOps. And this is particularly relevant because, for example, what happens if we are in an automotive production plant and we simply decide that we would favor to change our production cycle from day to night? Now, given the changed lighting conditions, does the visual inspection module still work with the same precision and accuracy as we are used to during daytime operations? And this is a really important factor for businesses as well, because particularly in Europe, where we have these high standards and demands towards reliability, security, and transparency on AI before it is even allowed to be put into service. This is relevant for security companies like the Munich Re, right, who now offered a insurance program that audits machine learning models before then offering insurance services and covering the liabilities that are connected to the deployment of AI-based supervision models. So if we now look at this convergence field between the value chains in enterprise AI and industrial AI, where we basically, as I said before, on the enterprise level, try to harness the AI and automation in order to drive the digital transformation of our business. On the industrial side, we complement that with using AI to drive the digital transformation of our industrial applications in order to enable new business models that scale across the organization's entire value chain. And this brings us to an entirely new field that has been emerging recently, which is called the AIoT, or the artificial intelligence of things, that will amplify and combine the value creation on device and process level in order to increase efficiency, optimize supply chains, improve quality, reduce costs, right, and provide these end-to-end services across the board. However, AIoT is not only based on AI, but requires a strong usability perspective as well. Because accessibility to technology, and in order to really successfully push a new business model and business idea, the usability aspect is exactly as important as the technology bit and the connectivity bit. Which brings us to a way of engineering this, which is the digital twin. Going forward, no business will work without digital twins. There will be a digital twin of everything. It can be a patient in hospital, where if we look at a lifetime digital patient folder, any AI will be perfectly able to diagnose any medical condition the patient might have. There will be entire digital twins of supply chains with real-time monitoring of the individual production steps of each of the individual goods. In engineering, any product should and will be virtually designed, built, and tested prior to a real life deployment. And that extends to basically any system that we can digitally design and enable. And I would like to introduce you now a use case that we conducted in Singapore, where the customer challenge was that in a silicon conductor production plant, the water cooling facility had to be engaged in a predictive service model. However, the entire production site was not built when the client approached us. So we had nothing to go on, yet the customers requested us to come with a solution that would allow them to immediately deploy a predictive maintenance in their semiconductor fabrication plant. So given the challenge, we sat down and tried to come up with a good solution. And the way that we approached it was we built an entire digital twin of the entire cooling water facility for that semiconductor fabrication plant. So we created models of all the different components that are involved in the fluid system: pumps, valves, heating, cooling exchange modules, and set up a virtual copy of the entire fluid control loop, as you can see on the left-hand side. So with this, we were then able to train our prediction model without using any historical data whatsoever. We purely trained our model based on the virtual model of the process cooling water cycle, and achieved an incredibly high accuracy when deploying the model to the real plant immediately after it went live. So due to the high availability that we achieved here, the customer was then able to achieve a 5% improvement of their plant availability and lower spare parts in inventory, because they could save on holding up these components on storage on site. And to just give you a quick idea on what happened, right? So we had a variety of heat exchangers, pumps, filters, control valves that were individually modeled and then fit together in this comprehensive flowchart. And then we trained our virtual models on purely the synthetic data that we generated out of our modules. And as you can see in the animated chart here, the historical data and the forecast have a near perfect overlap. And that could be even further refined once the plant went live. And we were then able to sort of feed in the actual historical runtime data. So with this, we were, and with the help of digital twin, we were able to accelerate the time to insight significantly, because we shortened the typical waterfall cycle of building the plant, ramping it up, then having it in operation for a certain period of time until enough historical data has accumulated, and then starting developing your predictive insight models only sometime later, which then in turn will cause even more delay due to the development cycle. We were able to cut this short and have the prediction model online the same point in time that the plant went live. And with these kind of concepts, Siemens developed artificial intelligence is really used in a very, very broad range of use cases across a broad variety of verticals. So we have optimization solutions and analytical solutions for processing time and quality inside production plants. We are engaged in trying to teach trams to drive autonomously. We have use cases in the profitability of 3D printing, where we do a live inspection and understanding the quality of these parts, and also a retrofit basically in case a printed component fails at a later point in time. How can we ensure that the component was working and created properly by the time it was delivered? We have robust gas turbine controls and so many more use cases. So if you require our support, Siemens Advantech Consulting really can help you in driving your digital transformation journey end to end across all verticals, and from the strategy design way up to the operations, we can be your end-to-end solution partner. With this, I would like to close my presentation for today with a final statement that we are really heavily invested in Oman, Dubai, and the UAE, as well as Saudi. So Middle East is really our second home, and I'm happy to start any discussions and answer any questions that might have come up. Thank you so much.
Thank you so much, Alexander. If there are any questions, if the audience can type them in the Q&A panel, Alexander will be very happy to answer them.
Hi, Alexander. It's Amr here. Thank you for your talk. It was very interesting. You can see that you have a lot of useful knowledge when it comes to this topic. What I wanted to ask you was, so you've been working in Oman now. You recently moved to Oman. We wanted to know kind of, for the organizations that you've been working with, have they kind of had a long history of using this type of technology, or are they very new to it? And kind of what size of organization should start to take this type of technology seriously? Yeah, I think that's what I wanted to understand. Is it kind of, can smaller organizations start to speak to you and experts like you to see how they can start to implement this? To start to implement robust systems to allow them to make use and make informed choices going forward. Maybe speak a little bit about that, if possible.
Absolutely. Amr, if you allow me, do you mean when asking about the companies that we've been engaging with, is your question particularly focused about the Middle East area or globally?
Yeah, sure. If you could speak about the Middle East, that would be great. If not, no issue. It could be globally.
Happy to. Thank you so much. All right. So, given the question on our clients, so typically, right, the broad range of customers that we've been tending to so far are, I would say, larger, medium-sized companies up to enterprise level. However, it is absolutely possible for even small-sized companies to approach us and engage us. And the question of should you is an absolute yes. There is no way, like I said before, right? There's no industry, there's no product, there's no service, there's no profession that will not be affected by digital technology in some way or another. And the digital technology is not only about artificial intelligence, but basically anything you can digitize and computerize. And that means if you do not have these capabilities, you're completely missing out on crucial ways to engage your customers, right? Especially looking at the younger generation who grew up as a digital native. If they cannot see that you as a business are able to provide the right information about yourself online and present yourself in a digital way to your potential customers, they will no longer approach you, right? Because why should I take the journey, right? To leave home, set myself into a car, drive down to Muscat and find your store in the mall if I am not sure that the trip will be worth my time because you have the product that I want to buy. So unless I am on a browsing spree and just want to walk through the store and let myself be surprised, then typically customers will immediately disengage from you. And this is a very, very critical component that is actually not really difficult to address. So you don't have to be a Google to do that. You can have your own Instagram channel very easily. You can have your own online store or at least a website very easily, right? And it's oftentimes it is small steps that provide a really large benefit to you. So absolutely, right? Each and everyone should educate themselves, should explore also the possibilities that emerge for you from becoming a player, right? Especially in these pandemic times, we see people starting their own digital enterprises who have nothing to do with digital businesses, right? But we see individual people, right? For example, just cooking and selling the meals that they prepared online, and having their products distributed over similar channels like Talabat, right? So single individuals, just through the means of digital technology, can become entrepreneurs, very successfully so, with very little knowledge. So since the accessibility of the technology today has improved so much, I would absolutely recommend each and everyone to start looking into this field and also engaging professional services in those cases where you then really need support.
Alexander, there's a question in the Q&A part. If you try to open that from Amru Al-Busaidi.
I can. So, thank you for the question, Amru. So the question is, what is the basis of your predictive model on the water plant client that I introduced earlier, since Siemens did not use historical data? All right, so what we did was we looked at the individual components that would be installed in the water cooling plant, right? So we looked at all the different types of valves, pumps, heat exchangers, anything that we have. And then in a first step, we built a digital model of those pumps and valves and everything, just based on the product specifications. That is a first step and the first element that you can take. And obviously, right, from this, you will only get perfect simulated data, right? Everything will behave according to specification. So in order to advance that a little bit, you can start inducing some variance, right? Some randomness to the data stream. And then a very useful on top step to this is that you acquire actually physical copies of these valves and modules and do small mock setups that will allow you to record small data sets that give you a more accurate idea on the behavior of the product in real-time circumstances, right? So with this, right, with this iterative approach, you can really start from a very, very small base, a very theoretical base, and then slowly get an approximation to the real status, where the accuracy of your prediction model will then constantly improve, right? And the final step, obviously, is then to look at the real deal and then get the historical data once you have it available. And the follow-up on if the model is a Bayesian model, to be honest, I don't know. I can clarify with our engineering team who was involved back at the time, but at the moment, I'm sorry, I have to pass on this question.
Thank you,
Are there
Alexander.
any questions in the audience?
Yeah. Go ahead. Yeah. Go on. Yeah.
So I was just asking, are there any more questions in the audience? All right, if not,
maybe just a last question from my side. With Oman focusing so much on its ports and manufacturing capabilities and industries, especially to export, because that's where they're looking at new revenue. Do you see that more and more factories and industries and plants get onto the AI roadmap?
here in Oman?
Yes, in Oman specifically.
So I would say the answer is a yes and no, right? So absolutely, we can see different individual pushes to massively digitize factories, given the ever increasing challenges imposed by the fourth industrial revolution. However, it is not only a matter of simply digitalizing everything and anything that is there, right? Before you take a decision to digitize a factory, especially if it is built upon legacy infrastructure and is functioning very well at this point in time, then you need to carefully consider what is the required invest that you need to take, right? What is the effort behind it? And then what is the benefit that you would be expecting out of it? And that needs to be carefully evaluated before taking a decision to advance the digitalization degree of a given plant. Depending on your product portfolio, right, you might then see that this is strategically necessary to do that, because maybe the next generation of products that you want to develop require new manufacturing procedures that you are not capable of implementing right now, right? I don't know, you might want to do additive manufacturing procedures in order to have a smart product at the ready, right? Then yes, you might need to upgrade your machinery accordingly. However, if your product that you're building is not expected to change in that regard, right? Then I would also refrain from updating your facilities, particularly if they are functioning at a very, very high reliability level, and the cost associated with it is actually lower, right? In some cases, right, clients typically approach us, right, with the question on, hey, what can we do in terms of what smart technology can we apply in order to save costs and reduce expenses and become more efficient, right? And sometimes they expect a really fancy answer, right, with Wi-Fi and connected products, blah, blah. But in some cases, it's really as simple as simply changing a light bulb, right, from a previous normal light bulb to an LED light. That will immediately cut your electricity bill by 70%, right? And sometimes the reaction to such an answer is a bit disappointed, right? Because it's not as fancy and has no AI in it. But sometimes old school is also a good way to go.
That's a very useful point you mentioned. Thank you.
Very welcome.
Do we have more questions from the audience?
Well,
I think the audience is quite satisfied with the presentation. Amar, do you want to say something, or shall I close the session?
Yes, I just wanted to say that we look forward, Alex. It was great to have met you recently, and for this today, to seeing how we can spread the word. We would be looking to do future upcoming events relating to AI in specific industries. So we'll definitely be in touch. This is, of course, this session has been recorded, so it will be shared on all of our platforms as we continue to build on our future upcoming events. Thank you for your time today.
Thank you so much.
Thank you so much, Alex.
Thank you so much, Oman. Goodbye.
Thank you. Bye-bye.
Thank you, Alex. Thank you, everyone.
Thank you, the audience. Thank you. Bye.